So we have use the graph to determine the solution of the equation to synthetic division to okay, to blah blah blah. You use the polynomial. Use the graph to determine the solution. So you have to read from the graph. I see it's x equals 4. Using the division, right? It's a process at 4. Using the division to verify that this number is a solution. Okay, which solution of the equation can be determined from the graph? Okay, you put that 4. What are the other solutions of the equation? Blah blah blah. So I have to copy it. Okay, here's the equation. We have x to the third plus 4x squared plus 25x minus 28 equals 0. Let me see if I... So x cubed plus 4x squared plus 25... No, minus, sorry. Minus 25x and minus 28. And my math lab shows the graph of a function of this function, just the portion of the graph. And from the graph, we read that x equals 4 is an x-intercept. They're saying to us also, hey, don't believe that x equals 4 is the correct reading. Show me that it's a solution, an x-intercept of this. How will I do it? Yes, if I substitute x by 4, but that's not what they're asking, but yes, I want to talk about this. This is awesome. So substitute x by, yes, substitute x with 4, and what should the answer be? If indeed, exactly, we know that, right? If it's not 0, then it's not the x-intercept. When y is 0, right, y 0 should give us x equals 4. Y equals 0 should give us x equals 4. X equals 4. So then 4 to the third plus 4 times 4 squared minus 25 times 4 and minus 28. I don't know whether that is 0 or not, so I'll punch it in the graphing calculator. So clear. So I have 4 cubed, which is 64, plus 4 cubed, which is 64, and minus 100. 25 times 4 and minus 28. If the answer is 0, then yes, obviously x equals 4 is a solution. Good. Now we are also asked, I think, correct me if I'm wrong, we are asked to find the other, how many solutions am I looking for now? 2 more, because the degree is 3. Once I have 1, I can only find 2 more. I cannot find more. Good. So how will I find the other 2? Synthetic division, because this is x minus 4 times, obviously, when x equals 4, x minus 4, if x equals 4 is a x-intercept, x minus 4 is a factor, right? So this must be something degree 2, because degree 1 times degree 2 will give us the degree 3. But the question is, how do I find this? And the answer is, you already told me. How? I do what? Synthetic division. Very good. Good. So what do I have in here? Careful. 4. What do I have here?
4. Oh.
Right under the free term, what should I have in here? Absolutely. We know that. Why? How do I know that? Because x equals 4 is a solution. Perfect. Very good. Well done. Good. So I copy 4. I'm sorry, I copy 1, and then this is 4. 4 plus 4 is 8. 4 times 8, 32. 32 minus 25 is 7. 4 times 7, 28, as expected, 0. So can anyone give us this polynomial?
X squared
Very good.
plus 8x.
Indeed. X squared plus 8x plus 7. So now I know that one solution is x equals 4, and the other solutions come from x squared plus 8x plus 7 equals 0. I'm hoping that I can factor. That's my hope. Can I factor this? The answer is yes, into exactly. So the other two solutions are, was there anything else that they were asking us to determine here? No. Very good. Anything else? Is there anything else you would like to? It was a very good example. Thank you. Yes, please.
Problem, but I have a question.
Yes.
When we're doing the rational function,
Yes.
there's a hole in the graph.
Yes.
What is? I was confused by that. I think I have to.
Let's look at an example. We'll pick an example right now.
Okay. I don't
Do
know.
you have an example,
No,
or
I don't.
I will make one up? Now, do you have other questions for me other than this?
Not a specific problem.
Okay, very good. So let's take a look at very good question. So let's take a look at f of x equals x squared minus 1 and x squared plus 8x plus 7. Okay, first I have to identify the type. Because once I identify the type correctly, I know a lot. I may know a lot. We'll see in a minute. What type it appears to be. Type 1, right? Because the degree of the top is, and the degree of the bottom is 2. So does this have a horizontal asymptote? Yes. The same degree of the same degree should I expect a horizontal asymptote. Would it be 0? No. No. Most probably not. Okay. Unless something very specific happens there. Good. So my next step would be definitely to do what? That's my hint for you. What will I do? If I drew the fraction line, what am I expecting you to say? Of course. Please. Because I have to find the domain.
Yeah.
If I don't factor, and then I have to find the x-intercepts. If I don't factor, I'll have more difficult.
So x plus 7.
Of course, that's how I pick it from here. And this is an agreement we signed 3 months ago. Well, 2.5.
X plus 1.
Very good. Before I touch the function, I have to state how many restrictions. How many?
2.
2. And they are?
Plus and minus 1.
Very good. That's how I write them. Because I need the chart. I'm summarizing everything in the chart. Why waste my time and write them somewhere else and then put them in the chart? What will I do next? Because now I'm allowed to do it. Because I wrote the restrictions.
Domain?
That's the domain.
Oh.
That's why I asked you what is a domain, and you said basically everything but -1 and 1. That's why I put the bar here. I don't have something to write in there.
When you do the x-intercepts?
Then, no, look at the function.
That's why I asked for help. I don't know.
So the x plus 1 cancels.
Correct. Obviously, this goes away, so the function is really this. So now, only the remaining factor gives the vertical asymptote. What happened to the one that disappeared? That is,
Oh, that's the whole.
that's the whole. So the factor that went away was x equals x plus 1. So I'm going to write next to it this, or underneath, x equals -1, a whole. What will I write under x equals 1, since x equals 1 doesn't go away and is still in the denominator of this fraction? What will I write for x equals 1? No, no, no. Horizontal is end behavior. No, no, that's okay. That's okay. We are getting used to this. This is new, right? So when the function is undefined, it's vertical. When I talk about end behavior, it's horizontal. But end behavior is here and here. Not somewhere in the middle. Good. So then I know infinities. But what I don't know is, thank you. What I don't know is the, exactly, the sign of the infinities. Exactly. I will not put these numbers in the chart, but I need to plug in 0.9 and 1.1 as close as I possibly can to 1. So when I plug in 0.1, what is the sign? I just need the sign of this with 0.9. 0.9 minus 1. So positive over negative, what would be the sign on the left-hand side? On this side, with 1.1, the top, and the bottom. Good, positive over positive. That's it. So I determine the vertical asymptotes, and I determine, exactly, and I determine the behavior near the vertical asymptote. There is only one. Now, I also have to write something here, but I cannot write infinities, because this is a hole in the graph. So I plug in -1 in this form. -1 plus 7. 6 over -2. I'm sorry? -1 plus 7. 6. -1 minus 1. -2. 6 divided by -2, -3. Let's talk about any behavior. What type is it? We already know. You can either look at that or look at this. It doesn't matter. Still type 1. So what is the leading coefficient? What is the leading coefficient? What will be the horizontal asymptote then? For type 1, leading coefficient over leading coefficient. 1. So 1, 1, y equals 1, horizontal asymptote. I only need 2 more things. One would be plug in 0. Please plug in 0. Yes, so -7. Good. When I plug in 0, I get -7. And now, final step. Please tell me, when is this fraction or function 0? When is the ratio 0? Say it again. Never when the denominator is 0. That's the problem, right? When the denominator is 0, the whole thing collapses. It doesn't exist. That's why we have the hole in the vertical asymptote. So when is a fraction 0? Exactly. When is this numerator 0? Very good. Please make sure that you put all these numbers and ordered pairs in the correct order. Ready? I need to make sense of the information before I even consider anything, right? Okay. From approaching 1, crosses at -7, 0. It comes down to an open point, -1, -3, and continues to cross the y-axis at 0, -7, and goes to -infinity. One more time. From approaching 1, crosses the x-axis at -7, 0. It passes through a point at -1, -3. It continues to cross the y-axis at 0, -7, and approaching -infinity on the left-hand side of the asymptote. We picture this? Yes? Okay. On the other side, from positive infinity, approaching 1. One more time. From 1, crosses the x-axis at -7, 0, goes to an open point at -1, -3, crosses the y-axis at 0, -7, and goes to -infinity. On the other side, from positive infinity, approaching 1. Ready? When we graph functions with asymptotes, what do we have to graph first? The asymptotes, yes. Very good. So, I'm graphing y equals 1. Remember, a function can cross the horizontal asymptote, but never the vertical asymptote. Okay. So we have at 1. And I will plot 0, -7, 1, 2, 3, 4, 5. This is bigger than I should. Okay. 2, 4, 6, 7. And I have -7, 1, 2, 3, 4, 5, 6, 7. And I want to plot this point and make the hole in there -1, -3. Right here. Ready? Ready? From approaching 1, crossing at -7, 0, coming down to this open point, continuing to cross at 0, -7, and approaching -infinity on the left-hand side of the vertical asymptote. On the other side, from +infinity to 1. And this is the function f of x that we just made up, x squared plus 8x plus 7 over x squared minus 1. Yes, we can convince ourselves with the graphing calculator. So in y equals, clear if you have anything, parentheses for the top, x squared plus 8x plus 7. Close the parenthesis, divide by x squared minus 1. Close the parenthesis. The calculator will not graph what? What is the horizontal asymptote? It has to be entered as a second function. So it's 1. Now let's think. Will the standard viewing window -10, 10, -10, 10 work? Yeah, because it crosses at -7, it crosses at -7. It should be okay. So I'm going to go to Zoom 6 and see what happens. It's coming from approaching 1, crossing at -7, 0. Has to have a blip somewhere here, definitely. This is the horizontal asymptote from +infinity to 1, crosses at 0, -7, and going towards -infinity. So now I don't see it there, but I can do this and check with second and table and put in, of course, I'm sorry, it goes back to default. So with second and table, and what do you want me to put in?
-3.
What did we plug in to get -3? -3 is the y value. I cannot plug in the y value.
-1.
-1. What should the answer be? Exactly. Exactly. It has to be error. So now with second and, let me go back to the graph. And I want to zoom in here. So I'm going to say between -2 and -4. You don't need to do this. So I want to zoom in by changing the viewing window. -2 to 0, and with a scale of 1, and y minimum 0 to, no, I didn't mean that. 0 to -3, and you already see it. -4. And graph. Really, what did I do? Oh, come on. Okay, what did I do? Oh, yes, of course. -4 to 0. I agree. Calculator is right. And graph. Here it is at -1. Ah!
It's just a dead pixel. You can't fool me.
Exactly. A dead pixel. I'll show you a dead pixel. Okay, very good.
So do we need to have to graph that? Do we need to like show that with like a circle to show that it's open like that?
Yep. Very good question, Mark. Thank you. Anything else before we go to type 3? Anything else before we go to type 3? This was type 1 with a hole in the graph. Because it was the same degree over same degree. The horizontal asymptote is 0 for type 2. Say it again, Tim. Yeah. Okay. So let's say f of x equals 1 over x plus 1. This is type 2. Negative infinity to infinity. Please give me the domain. What is the domain of this function? Really? Okay. I want you to. He came to his senses quickly. Okay, does x plus 1 go away? No. So then x equals -1 will be? Thank you. Which means infinity is left and right. So please plug in -1.1 and -0.9 and give me the sign, just the sign. On the left, the sign is? Yes, because -1.1 plus 1 is negative, positive over negative is negative. I agree. On the right-hand side is? Positive, I agree. Is this okay, everyone? And behavior for type 2. Of course, this is type 2. Always. And behavior for type 2. 0. So y equals 0 is the horizontal asymptote. Please plug in 0 and tell me what you get. 1. Is this function 0? A fraction is 0 when? Yes. Can the numerator of this function be ever 0? No. So there is no x-intercept. No x-intercept. I cannot make y 0. Good. That's it. So now let's think about it one more time. From approaching 0, it's coming down to -infinity on the left-hand side of the asymptote. Then it's coming from positive infinity, crossing at 0, 1, and going towards 0. One more time. From 0, going to -infinity, from positive infinity, crossing the y-axis at 0, 1, and going towards 0. Easy? Yes? Okay, so let's do it. When I graph a function with asymptotes, what do I have to graph first? I'm going to ask you that in chapter 4 again. For a different function, though. Yes? So x equals -1. Good, so 0, 1 is here. Horizontal asymptote for this function is an overkill. We already have it. It's the x-axis. So now let's graph from approaching 0 to dropping to -infinity. Don't touch anything. Do not touch any of those. It gets closer and closer, but no touch. On the other side, from positive infinity, crossing, going towards 0. So this is f of x equals 1 over x plus 1. Type 2, the only difference from type 1 is the horizontal asymptote is 0. Very good. So now we are ready for type 3. Nothing beyond type 3 should be part of this course. So if you encounter something in homework, do it, answer the questions, but I'm not going to test you on anything beyond type 3. I don't test pre-calc for anything beyond type 3. No. It requires way more knowledge than just what we can do in this class. On page 427, I would like anyone to choose a type 3, please. If you say 76, 76 is not type 3. Type 76 has degree 4 at the top and 2 at the bottom. And that's not type 3. So can anyone choose a type 3? If you don't want to choose, I will choose 85. $85 okay? Okay. Perfect, 85. 85 on page 427. F of x equals x squared plus x minus 6 divided by x minus 3. What type is this? Is it type 1, type 2, or type 3? No, I did not fall asleep. I just wanted to make sure that you're here with me and following. Good. What will I do right away? And this is my hint for you.
Factor.
Yes, I'm ready. Not all rational functions will be factorable at the top. I don't know. Anything can happen. But this one is. So the top is? Very good. Awesome. So let's start the chart. No. It has to go away with an identical factor. So since they're not identical, yes. Good. So far, so good. Perfect. Good. Domain. Thank you. Notice that 0 must be in the chart no matter what. Even if it eventually it's a hole in the graph, or if it's a horizontal vertical asymptote, I don't care. 0 must be in the chart at all times. Okay, very good. So does x minus 3 go away? No. So what do I conclude that x equals 3 equals is a vertical asymptote. So now you will plug in something very close to 3, left and right, and you will tell me the signs. It is better to do it here than here. It doesn't really matter. It's the same function. So with 2.9, sign. 2.9. 2.9. So the sign on the left is 3.1. 3.1. 3.1. Do not assume, because remember there are 4 options. This is one option, this is another option, this is one option, and this is the other. You have to check both sides. Good. Perfect. So now give me the x-intercepts of this function. When the function is 0. When is the function 0? And -3 and? Very good. Awesome. -3, 0, +2, 0. Please plug in 0 in this function, because I need to find what happens at 0, which is the y-intercept. Here's how I do it. Plug in 0. Indeed. I'm done with one exception. We have not talked about the end behavior. The rest is done. No symmetry. The function cannot be symmetric with vertical asymptote at 3. Cannot be symmetric with respect to the y-axis, and it cannot be symmetric with respect to the origin. So now here's the question. When the degree of the top is exactly by 1 unit bigger than the degree of the bottom, there is no horizontal asymptote. Type 3 does not have a horizontal asymptote. Only type 1 and type 2 have horizontal asymptotes. This one does not. Here's what happens here. I will use the synthetic division or the long division to divide and find the quotient. Can anyone tell us what would the quotient, what would be the degree of the quotient? When we talk about degree 1, which function do we have in mind? That will be the slant asymptote. The quotient I get from the division will be not horizontal, but it will be a line that is slant. And that will be the slant asymptote of the function. That's the only difference from the other two types. So let's use a long division or synthetic division to find the quotient, only the quotient. So, what goes in the box if I use synthetic? Perfect. So now please tell me the coefficients for
1,
yes.
1,
Yes? Very good. I copy 1. 3 times 1 is 3. I put it up here. 1 plus 3 is 4. 3 times 4 is 12. What goes in the box? 6. But I only want the quotient. Quotient equals slant asymptote. So y equals, what is the quotient? Say it again. That's it. Now, how do I graph this? Sorry. How do I graph this? Is it with a positive slope or with a negative slope? Right. So that would be the end behavior of the function. The function must follow the slant asymptote like it did with the horizontal one. So what would be the end behavior then? And now we're done. We'll have other examples in a minute. So the only difference is the slant, nothing else. Everything else we've determined, we've done the same for all the other type 1 and type 2. Okay, so from negative infinity crosses at negative 3, 0, crosses at 0, 2, which is the y-intercept. It has 2 x-intercepts, sorry. Okay, okay, yeah, I started somewhere else, I'm sorry, my mistake. So that's how I knew, what am I doing? Okay, so negative infinity crosses at negative 3, 0, crosses the y-axis at 0, 2, crosses again the x-axis, and goes towards negative infinity. On the left-hand side of the vertical asymptote, one more time. From approaching the slant asymptote towards negative infinity, it's coming up, crossing at negative 3, 0, crossing the y-axis at 0, 2. I don't know where it turns, but it must turn because it crosses again at 2, 0, and it goes towards negative infinity on the left-hand side of the vertical asymptote. Here, this makes no sense, right? How can a function connect infinities? Well, we can, if it does this. This function connects infinities. It's x squared. So there is a minimum here. So let's graph. When I graph a function with asymptotes, what do I have to graph first? That's all I care about. Nothing else matters. Just my little chart. Okay. I graph the vertical asymptote, which is x equals 3. But now I have to graph the slant asymptote, which is y equals x plus 4. X and y intersect. When x is 0, oops, when x is 0, how much is y?
4.
Good. So 0, comma 4. When y is 0, how much is x? Negative 4. So this is my slant asymptote. I'm back to my chart. And I'm ready to put in my -3, 0. My 0, 2. My 2, 0. Ready? From approaching the slant asymptote towards -infinity, crossing at -3, 0, going to cross at 0, 2. I don't know if it turns here. I doubt. I think it continues a little bit, but this is insignificant. We're going to check with the graphing calculator. I don't think it stops here. I think it goes further. Okay, so it continues to cross at 2, 0 and going towards -infinity. That's the left-hand side of the vertical asymptote. Now on the right-hand side, it must be very clear. So I don't know what happens here. I have to check this, and I definitely don't have that minimum. And this is type 3. Any questions? So how do we get the slant asymptote? Only because the degree of the top is by 1 unit higher than the degree of the bottom. And when we divide, the quotient is aligned. So in y equals clear, whatever you have, both y1 and y2, what was the function? 85. X, in parentheses, please. X squared plus x minus 6, close the parenthesis, divide by, in parentheses, what was it? X minus 3, yes. X minus 3. What else will I have to put in? Because the calculator is not as smart as you are. Say it again, Tim. Exactly. It will not graph it. So x plus 4. Now let's think about the viewing window. I may not be, if I want to see the whole thing at once, I don't know how high this minimum is. I have no idea. Sorry, no problem. So I'm going to say between -6 and +6, or even more because there's that maximum. I'm going to say 10 for now. With a scale of 1, it's okay. Y minimum, I don't really care about a lot of minimum for Y. I'm going to say -2 for now. But Y maximum, maybe 40. I don't know. And I'm going to put a scale of 5. And let's see what happens. According to my little viewing window there, it's not good enough. Oh, it is good enough. So here it is. It's coming from -infinity, crossing at -3, 0, crossing at 0, 2. It continues, as you see. It goes a little bit higher. We'll investigate this in a minute. Crossing at 2, 0, and it's coming towards or going towards -infinity. On the other side of the vertical asymptote, coming from +infinity and going to +infinity, and it has to have a minimum. So since we're here, let's do the minimum first and then come back to the maximum. So for the minimum, second and calc, I want the minimum 3. And I'm going to say, so this is, the vertical asymptote is a -3. So I'm going to put 3.5. 3.5 is the left bound. And since I don't want to put, I can put 6. So this is 2, 4, 6. Yeah, I had 10 here. So I can put 7 as the right bound. Definitely it passed the minimum and no guess, and it's giving us the minimum as being 5.4. Where's my chart? So the minimum is 5.4 and the minimum value is 11.9. So that's the minimum. Now I want to investigate this piece because I don't believe it turns here, and it doesn't appear that it turns here. So I'm going to say that I want to find the maximum for x between -1 and x equals 2. So second and calc, I want a maximum now, which is 4. And I'm going to say between -1 and 2. And just give me the maximum. And the maximum is at 0.5, not at 0. So I have to go back and make a small correction. I'm not going to erase anything because I want my professor to know that I know what I'm doing. So, but the height is 2.1. It does not turn on the y-axis as expected. Okay, so it's at 0.55. I have to insert the point here, 0.55, and this is 2.1. So I go back. I will not erase anything. I will just do this, which shows that this is the maximum. The maximum is not on the y-axis. I will not do anything. I will not erase anything. I will just make the correction as is. And this is type 2. So the only difference, type 3, forgive me. The only difference is the slant asymptote. Everything else is the same. So please choose another function.